Okay, I'm going to record here. We're going to look at period 2 and basically make a model for each of the atoms in period 2. Make sure while you're watching this recording, you've got your periodic table. And again, we're looking at lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And we're going to make a model of each of these. As I scroll down, you won't have this part of the periodic table anymore. So make sure you've got it beside yourself. In class, we finished up boron, and we're doing the name, and then a model, and then the valence electron. So let me just kind of catch up to myself here. I wanted to do the symbol here, so this is Lis. Beryllium is going to be Be, solid. Boron is just Bs. Okay, it's a solid. Next one we're going to do is carbon on period 2. It's a good old carbon, and it's C solid. We'll get a model for the carbon atom. You'll notice it's number 6, so therefore it's got 6 protons. Check out its atomic mass on carbon. Again, you're looking on your periodic table, you'll see it's 12. So that 12 minus 6, so therefore there's 6 neutrons. I'll put a circle around these. This is the nucleus. I'll do that for these two as well here, just so that we're looking consistent on our models. There we go. And do another one up there. A little bit tight, a little messy, but it's all good. Okay, our electrons, this is the stable configuration. This is the ideal. Now, carbon is not stable. Boron's not stable. Beryllium, lithium, none of these are stable yet. But there are 2 electrons can go into the first orbit, and if there's 2 available, they have to go there. Well, carbon's got 6 protons, therefore 6 electrons, so it's definitely got 2 electrons for the first orbit. Okay, if we use 2 electrons, there's only 4 more left. 4 electrons right there. So not quite the right number. That's the stable number 8. We'll do a basic drawing here of the carbon electrons. So just 4 of them. And carbon being a nonmetal, it can actually take another 4. And see, if we take 4, we'd get 8, right? With boron having 3, if we took 5, we'd get up to 8. On beryllium here, see, if it gave away 2, we'd be down to our 2. We'd get stable. Ah, right. See, if lithium gives away this 1, it gets down to stable, down to 2. So that's what's going on here with those valence electrons. They're either being given away or they're being taken. Let's do nitrogen next. So we'll write the name nitrogen. Just got to get my marker. There we go. So good old nitrogen. N2 gas. It's diatomic. It's a gas. But we'll just do the nitrogen atom. So we're not going to draw that molecule there. This is actually a molecule, right? Where two atoms are bonded together. We're going to get our protons on nitrogen. Again, looking at our periodic table, it's number 7, so 7 protons. Check out nitrogen's mass. Look carefully again on your periodic table. It's got 14 as its mass, so therefore 7 neutrons. Protons plus neutrons got to give us our mass. Now we distribute, configure, we place our electrons in the right place. There's 7 protons, therefore 7 electrons. So certainly I can put 2 here. Okay, if I use up 2, I've got 5 more. So I can put 5 electrons here because I can put up to 8, so that's no problem. Oh, it's not quite stable. This is why nitrogen is reactive. It's also why it forms a bond with other nitrogen atoms. Let's draw the model here for nitrogen. We're going to put 5 electrons. 1, 2, 3, 4, and 5. So it's going to take how many to make its 8? It can take up to 3 electrons. You'll see its charge on there is -3 as well. Let's do oxygen. Again, its name and its symbol, O2 gas, that's how it exists. We're just going to do an oxygen atom. We're not going to draw this molecule here. We're going to draw an oxygen atom. So a single oxygen atom has how many protons? Again, looking on my periodic table, it's number 8, so therefore it's got 8 protons. Look at my mass. Again, look at your periodic table. The mass is 16, so therefore 8 neutrons. Put a little circle around us here, so that's our nucleus. Now we've got 8 protons, therefore how many electrons? 8 electrons. 2 of them are going to go here. If you've got 2 electrons, they go there. How many more do we have? We've got 6 more left over. There could be up to 8 here. Oh, not perfectly stable. It's not the perfect stable number. Let's draw a little model of just those valence electrons. 1, 2, 3, 4, 5, 6. So not quite. It can take, this can take 2 to kind of balance out and give us its 8. Let's go to the next one. Let's go to fluorine. So good old fluorine. And looking again, its proper way to write its name and its symbol, F2 gas. It's in group 17. They're all diatomic. Let's just do the fluorine atom. Check out how many protons it has. Its number, what number is it on the periodic table? Number 9. So it's 9 protons. Its mass is 19, so therefore 10 neutrons. Draw the circle around it. Let's draw where our electrons would go. We have 9 protons, therefore, how many electrons? If it's an atom, it's got 9 electrons. So 2 of them are going to go here. And there's going to be 7. Oh, almost. Wow, it's almost the magic number 8. So let's draw. There's going to be 1, 2, 3, 4, 5, 6. Oh, not quite. It can take 1. Ooh, there's a cool pattern here, right? Look at this pattern. 4, 3, 2, 1. Fluorine. We're going to do neon. Neon is a noble gas. Good old neon, Ne, just a gas. Do the model here. How many protons? Again, looking on our periodic table, neon is number 10, so therefore it's got 10 protons. Neon's got a mass of 20, so therefore 10 neutrons. Draw a circle. That's the nucleus. There's your mass, adding up to 20. All right, we've got 10 protons, therefore 10 electrons. 2 here, 8, and that's a perfect number, perfectly stable, 2, 8. If you draw the model for argon, you're going to see something interesting. Let's draw the valence electrons on neon. 1, 2, 3, 4, 5, 6, 7, 8. Stable. Does not give, well, it's a non-metal, so, or take. So it doesn't do whatever, it's not reactive, it's stable. Okay, that's it. Make sure to watch this, write all these ones out, and you're going to want to be able to make a model of the first 18. So we did all of period 2, but you want to be able to do the same kind of model for the first 18. Okay, take care. Have a good day. Chemistry.